on this. Okay. So we are moving on to lesson 5.5 on the properties. All right. So here we're looking at 3 key properties. I'm not looking at all of them, guys. I'm just looking at 3 properties with you. And remember, since this is being recorded, you can look over it later on if you miss anything. We're looking at the commutative property first. And the commutative property has to do with order. As in the order, you simplify an expression, doesn't make a difference. The commutative property works for addition. The commutative property of addition says, if you add A plus B, this will produce the same result as adding B plus A. So the order you do the problem in doesn't make a difference. It works for addition. In particular, here's an example, guys. 5 radical 2 plus 6 radical 2. This will give you the same answer as 6 radical 2 plus 5 radical 2. Whether you add it on the left side or you add it on the right side, you're still going to get the same thing. And that would be 11 radical 2. Now, the commutative property also works for multiplication, guys. So once again, for the commutative property of multiplication, it says that the order you multiply makes no difference. As in, if you do A times B, this will give you the same answer as B times A. It doesn't make a difference, guys. So in the case of the multiplication, here's an example. If I was multiplying square root of 3 times the square root of 2, this would give me the same answer as multiplying radical 2 by radical 3. It doesn't matter how I multiply them, both ways will produce the same answer, and that is radical 6, okay? So the commutative property works for multiplication and addition. Now, guys, when you go into my math lab to do these problems, you're just filling in what is missing. What is missing from this problem? That's all you're doing, okay? So here comes the second property we're going to look at out of 3. And that is the associative property. Now, the associative property, guys, has to do with grouping. All right, so grouping involves, obviously, a set of parentheses, but you could also see the parentheses in the commutative property as well. So the grouping is completely different. The grouping says this, okay? You group the problem, the group you do the problem in makes no difference, okay? The terms are not moving around, okay? The grouping is moving around. So the associative property also works for addition and multiplication. That's it, okay? So for the addition part of the associative property, it says, if you're finding the sum of A plus B and adding it to C, this will produce the same result as adding A to the sum of B plus C. Notice, guys, what's on the left versus what's on the right. You will notice, okay, the grouping symbol, the parentheses are moving. The terms remain in the same sequence, in the same order. So here, this is about the grouping symbols. By the way, the associative property, guys, here's an example of it. If I were to add, let me see here, quick example, specific example here. If I were to add 2 plus 3 and then add a 5 to it, this would produce the same answer as adding 2 plus the quantity 3 plus 5. So both of these on the left and on the right will produce the exact same answers. Now, the associative property also works for multiplication. Now, here's how the multiplication works. Again, this is about the grouping, guys, so be careful with this. So if I were to multiply A and B together, then multiply it by C, this would produce the same answer as multiplying A times the quantity B times C. So again, Notice the terms remain in the same sequence, but here the grouping is changing. So here is an example, guys. Quick example. If I multiply the quantity 2 times 3 by 5, this would produce the same thing as multiplying 2 times the quantity 3 times 5, okay? That's the associative property of multiplication. And then the third property we look at is the distributive property, which we use very frequently. And the distributive property, guys, says this: you're multiplying over addition. So it's multiplication over addition, the distributive property. Multiplication, here, let me abbreviate here, over addition. Multiplication over addition. So guys, if I had A times B plus C, the quantity A times B plus C, this would give me, I would take the A and multiply it by everything inside the parentheses. So this would give me A times B plus A times C. Notice the A is being multiplied by each term inside the parentheses. To be a bit more precise, let's look at the specific example here. Square root of 5 times 2 plus the square root of 5. If I were to take the square root of 5 on the outside of the parentheses and multiply it by each term inside the parentheses, because obviously I can't add what's inside the parentheses, this would produce 2 radical 5 plus radical 5 times radical 5, which is radical 25. And guys, if you can simplify a radical, you must simplify it. You don't have to be told to do it. You just do it automatically. Square root of 25 simplifies to 5, and then you keep the 2 radical 5, and there's your answer. And just like that, guys, you're done. Okay? So 3 key properties. The properties are the associative property, the commutative property, and the distributive property. Those are the 3 properties you're going to see on the assignments as well as on the test. On the test, I believe there's 2 questions that refer to these properties, okay? But they're easy, guys. When you're finished, what is the attendance code? I haven't given out the attendance code yet. I have to go and retrieve an attendance code for you guys. All right, Kui, I see you. So guys, that's it for lesson 1.5. Very short and to the point. So the work is actually coming from lesson 5.6 and 5.7 tonight, okay? So lesson 5.6 is next, guys. Remember, 5.7 is the last lesson. And so once we're done with this, guys, we'll be ready for the test, which is happening next Thursday in class in S204. So we're moving on to lesson 5.6, and lesson 5.6 has to do with exponents and scientific notation. All right, guys. So we're going to go ahead and get started with some rules of exponents. So we've got the product rule. Product means multiplication. And the product rule basically states this. When you multiply with the same base, you are to keep the base, and add the powers together, guys. Add the powers together. So here, if you're multiplying x to the m times x to the n, you would keep the x base and add m plus n together. So if you have something like this, 9 to the 3rd times 9 to the 5th, you keep the base 9 and add the powers together. So you get 9 to the 8th power. And that's it for the product rule, guys. Very straightforward, okay? I'm not gonna lingo on this one because we don't have too many questions involving these type of problems, but you need to know when you're multiplying, add the powers. Okay, so now the next rule is about the quotient rule. Just some basic rules of exponent. The quotient means division, by the way, states this: when you're dividing with the same base, keep the base, subtract the powers. You're going to subtract the powers, guys. So for this one, you would keep the base m, subtract m minus n and that's it. Now, on this one, here's a specific example. If I have x to the 10th power divided by x to the 4th power, I would keep the base x, subtract 10 minus 4. So the answer would be x to the 6th power. And that's it. All right. Now, here's another one, guys. Actually, you know what? This is one of the problems on the assignment. So let's go ahead and do this problem right here. It's 2 to the 4th over 2 to the 5th. I don't remember which assignment this is in, but you will see this in one of the assignments, guys. So I'm just going to go ahead and go over it. All right. So on this one right here, guys, it's up to you how you want to tackle this, but here's a very easy way for you to deal with this, okay? So for the first fraction, I've got 2 to the 4th power in the numerator. So 2 multiplied by itself 4 times. And the denominator, I have 2 multiplied by itself 5 times. I'm writing it out so you guys can actually see what's happening here. Now I'm going to cancel out sets of 2's. When I cancel out the sets of 2's, I'm left with 1 over 2. That's what the first fraction simplifies to. I'm going to move on to the second fraction. Do the same thing. 3 to the 3rd is 3 times 3 times 3. And then in the denominator, I have 3 to the 5th power. And 3 to the 5th power is 3 multiplied by itself 5 times. So again, I'm going to cancel out pairs of 3's. And what am I left with? 1 over 3 times 3, which is 9. So now once you get here, you can go ahead and add these together by finding the LCD between 2 and 9. The LCD between 2 and 9 would be 18. And remember, guys, when you're dealing with fractions, if you change the denominators, you must change the numerators. So in this one right here, I'm going from 2 to 18. So I would go ahead and multiply 2 times 9 to get to 18. So I'm going to do likewise to the numerator. So this becomes 9. Over here, to go from 9 to 18, I multiply it by 2. So I'm going to multiply the numerator by 2 as well. So here, once the denominators are alike, I'm going to keep the denominator, add the numerators together. So here's my answer, 11 over 18. By the way, guys, you can type this into your calculator and let your calculator help you out. Save those questions. If you don't know how to do it on your calculator, save it for later. I will answer those type of questions for you. But in the meantime, if you want to play around with your calculator, your fraction key typically looks like this, A/B/C. And if you don't see this one, you might see something that looks like this, perhaps, okay? So play around with your scientific calculator and find out what's on there. Now, on the graphing calculators, it depends on which one you have as to whether or not you have the fraction key. If you've got a newer version of the graphing calculators, they do have a fraction menu. And so if you have questions about your calculators, guys, save them for later. We'll talk about them later. Okay, so now I am going to go ahead and move on to the scientific notation, which reminds me, I forgot to mention something else about the powers. So let me go ahead and mention it now, guys, because this is important. Whenever you have a base raised to the 0 power, anything raised to the 0 power is always equal to 1. So if you have 10 raised to the 0 power, that will be equal to 1. We are going to see this later on. That's why I'm mentioning it to you now. Anything raised to 0 power is equal to 1. Now, scientific notation is what we're moving to. This is where you are going to be writing typically very large numbers or very small numbers in scientific notation in multiples of base 10. Very large or very small numbers and multiples of base 10 and multiples of base 10. Now, normally I would look at the national debt with you guys. If we were in class together, I'll try and look at it later, but for now I'm not gonna pause and go look at the national debt with you guys. I'll see if I could do it later before you leave class, okay? So the reason why I talk about the national debt, it's because obviously it's a very large number. That would be the ideal case for us to talk about how to write numbers in scientific notation. Okay, so we're basically taking numbers and rewriting them in multiples of base 10, guys. Now, when we write scientific notation, it's in the form of a times 10 to the nth power. The a value must be a number less than 10, but greater than or equal to 1, meaning it can be 1 non-zero digit in front of the decimal, guys. You can only have a non-zero digit in front of the decimal, okay? Here, let me write this down. In front of the decimal. And these questions will be on the test. So when you write scientific notation, you're only allowed to have one non-zero digit in front of the decimal. Now, the power, n is positive if the number is larger than 10, or if the decimal is moved to the right. Okay, I'm running out of room here, guys. Decimal is moved to the right. So if you move the decimal, not the right, the left, what am I talking about? If you move the decimal to the left, yes, the exponent is going to be positive. On the other hand, the exponent is going to be negative if you move the decimal to the right. I am going to erase this, guys, so I can write the next part of it because I'm running out of room here. Let me see here. Okay, so I'm going to erase it. Remember, the video will come up shortly. All the videos are compiled in the folder and Blackboard, guys, on the virtual video lessons. That's what it's called, okay? Now, the exponent is negative if the number is less than 1, or if the decimal is moved to the right. All right, guys. So now let's go ahead and take some examples. So one of the numbers I can tell you off the top of my head is the population of the US. The US population is currently at about 330 million individuals. We're still in the middle of doing the census, guys. Is it done already? I think it's done at the end of this month, okay? So this year we went through our population counts, the census. So hopefully you guys did your census. So here's a very large number, guys. This reflects the number of individuals living in the US. And so here, if they wanted us to rewrite this in scientific notation, we would go ahead and first identify where the decimal is at. And the decimal would be at the end of the number. We take the decimal, we move it over 1, 2, 3, 4, 5, 6, 7, 8 places until we get that one non-zero digit in front of the decimal. Okay, I saw, let me see. Hold on a second. Tanio, 33, what do you mean?
Oh no, I was mislistening. I thought you meant start from the decimal place at the number, like 33 and then the zeros?
No, at the end of the number. Yeah, at the end of the 330 million. Yeah. And then you want to move that decimal until you get one non-zero digit in front of the decimal, okay? So now you can go ahead and write out the 3.3, which is that number that is less than 10, but greater than or equal to 1. And then times 10 raised to however many digits you skipped over to get to this decimal right here. How many digits did we skip over? We skipped over 8 of them. And guys, that's how you express 330 million in scientific notation. Questions about this? No questions? All right, guys, so here comes another one. Now, let's say this time the number is 0.000043, and you need to express this in scientific notation. Well, you would take your decimal and move it over 1, 2, 3, 4, 5. Keep moving it until you get to that one non-zero digit in front of the decimal. So you would end up with 4.3 times 10 to the what power, guys? What do you think? To what power, guys?
-6.
-7, actually. Okay.
Oh,
Now you notice I moved the decimal to the right, so I am going to end up with a negative exponent. Furthermore, this decimal right here is way less than 1, guys. So yes, the exponent must be a negative. Now, every once in a while, they give you a number, such as this one right here, 6.46 times 10 to the 5th power. And they ask you to write this in decimal notation. This is the same thing as saying, take this out of scientific notation. Rewrite it without scientific notation. So decimal notation is basically your regular numbers without scientific notation. Just your regular numbers, okay? So here, you would take your decimal and move it, this case, to the right, okay? Because the exponent is a positive, and you would move it 5 places to the right. So if you move it 5 places to the right, guys, this is what you're going to end up with, okay? 6 and then 4 digits, okay? I mean, I said 4 digits, not 4 digits, Shazam. Okay, I didn't move it correctly. Okay, let me try this again. Here, let me write it out for you guys so you can see. Okay, 6.46, I'm gonna move it 1, 2, 3, 4, 5. Fill in zeros for all those missing place values, okay? So fill in the 0 for the missing place values, and then guys, this is what you end up with, 640,000. 640,000, okay? So that's decimal notation. So you have to be able to switch back and forth between scientific notation and decimal notation. So any questions about this one, guys? Now, let's go ahead and multiply in scientific notation, okay? Let's do a little bit of multiplication in scientific notation. So this time, I am going to multiply 6.3 times 10 to the -6 power by 3 times 10 to the -3 power. Now, for those of you who were wondering, why were we talking about the rules of exponents? This is why. So here, when you're multiplying in scientific notation, you would take the 6.3, multiply it by 3. So you grab your calculator, you multiply, you get 18.9. So we multiply these two together. Next, guys, you keep the base 10 and then add the powers together. Why are you adding the powers? Because you're multiplying. When you multiply with the same base, you keep the base and add the powers together. So -6 plus -3 gives you a -9. Now, guys, here's the big question. Is this correctly written in scientific notation? That's the big question. Well, when you write scientific notation, you're only allowed to have one non-zero digit in front of decimal. In other words, this needs to be less than 10. Obviously, it's greater than 10, so this is incorrectly written in scientific notation. To write it correctly in scientific notation, we'll take the decimal from here, move it over one more place to the left. Because we're moving it to the left, that's going to increase the exponent by 1. So the correct scientific form for this would be 1.89 times 10 to the -8th power. And there you go. Any questions, guys? Nothing? All right, so now I am going to do a division problem, and then I will go ahead and move on to the last lesson, okay? So guys, here we go. Let's see here. On this one, I am going to do 2.1 times 10 to the 13th power divided by 7 times 10 to the 8th power. Now, for the division part, guys, this is where the rule of exponents comes in, the quotient rule. So first, you want to take the 2.1 divided by 7. 2.1 divided by 7 leaves you with 0.3. 0.3, 0.3. You keep the base 10. And then since you're dividing with the same base, you are going to subtract the powers together. So 13 take away 8 leaves you with 5. Once again, guys, this is incorrectly written in scientific notation. Why? Because you have a 0 in front of decimal, and 0 is less than 1. That number in front of decimal must be greater than or equal to 1. So you got to take the decimal from here and move it over one more place to the right. Because you're moving it to the right, that's going to decrease the power by 1. So the correct form of this will be 3 times 10 to the 4th power in scientific notation. And yes, guys, you will get scientific notation problems on your calculators, on the test. And yes, you can use the calculator on the test, and you can do these problems on the calculator. Now, if you're going to do this one on the calculator, you can type it exactly like you see it. The only difference is you want to type in it as a division problem. So you would do the numerator 2.1 times 10 to the 3rd, close the parentheses, divided by the denominator inside a set of parentheses, and it works, guys. Play around with it, okay? That's the only way you're going to find out if it works. If you try it on your calculator, it doesn't work out for you, just hang on. Towards the end of class, I will answer your questions about how to plug it into your calculator to get it to work, okay? So guys, finally, I am going to move on to the last lesson of chapter 5 in preparation for the test next Thursday. So here we are, guys. Lesson 5.7. And lesson 5.7 has to do with the sequences. There's 2 types of sequences we're looking at. We are looking at first the arithmetic sequence. Now, guys, the arithmetic sequences, all right, they require formula. I will be giving you the formulas on the test so you don't have to memorize them, okay? Now, when we talk about an arithmetic sequence, we're looking at a sequence or a set of numbers where each term is found by adding a number to the previous term to get the next one. Now, this number which is added to each of the previous terms to get the next one is referred to as the common difference. And to reference this, we use D, the variable D, to reference the common differences. So that number that we keep adding over and over again to get to the next terms in that sequence is called the common difference. Now, guys, to get started, I am going to look at a set with you, an arithmetic sequence. So, guys, here it is. It consists of the terms 7, 3, -1, -5, -9, -13, and so forth and so on. So you are given this set of numbers right here, this sequence of numbers, okay? And the question will come up to go ahead and find the next 2 terms in the sequence. So the first step is to go ahead and identify the common difference. What is the common difference? What is that number that is being added to each term to get to the next one? In other words, to go from 7 to 3, what do you add to 7? By the way, subtraction is a form of addition too, guys, okay? So to go from -5 to -9, what do you add to -5 to get to -9? That would be a -4. So the common difference, guys, is -4. Now, if you're not sure how to do it, just choose 2 consecutive values and subtract them. Find the difference between 2 consecutive values. So for example, here, I could pick, I don't know, -1 and -5. So I would take -5 minus -1, and that would leave me with -4. So there's my common difference. And that's it. Okay? So now I am going to go ahead and find those two missing terms, the next two terms. Since I now know what the common difference is, all I have to do is add the -4 to get the next two terms. So if I add -4 to -13, that's going to give me -17. And then I'm going to take -4 and add it to -17, and this will give me -21. So there's my next two terms, guys. Any questions? All right, guys. Now, here's the big one. One of the questions they will ask you is, what is the 20th term in this sequence? What's the 20th term in the sequence? So rather than continue your pattern, your sequence right here to the 20th term, we can use a formula to calculate the 20th term. This is the formula, guys, I am going to provide to you on the test, so you don't have to worry about memorizing any formulas. So guys, the formula we use to calculate, here, let me write it down, to find any term in an arithmetic sequence is AN equals to A1 plus N minus 1 times D. Now, let me identify some of these terms for you, okay? So A1 always represents the first term in a sequence. First term in the sequence, guys. First term. Now, N represents the term number you're looking for. The term number you're looking for. In this case, I asked you to find the 20th term. So N would be 20. And of course, D is the common difference, which we've already talked about. And then AN represents the value of the term. All right, guys. So going back to the sequence again, which was 7, 3, -1, -5, -9, -13, okay? We figured out the common difference is -4. Now, 7 represents your first term, okay? And then they wanted us to find the 20th term. So since they want us to find the 20th term, this means that N would be equal to 20. So now, guys, you go back into your formula and you substitute everything in. So this would be A sub 20, or the 20th term, equals to the first term, which is 7, plus the term number, which is 20, minus 1, times D. What is the D value? -4. And then you grab your calculator, guys, plug it into your calculator and work it out. So on your calculator, you just do 7 plus 19 times -4. And this would produce your answer. And the answer for this one is going to turn out to be a -69. So rather than continuing the terms out, you can just use the formula and calculate any term in the arithmetic sequence, guys, just using that formula. Questions? All right, let's go ahead and do some additional examples, guys. So here's the next one. So listen to this one right here. Example number 2. Find the first 5 terms of the sequence if A1 is equal to 8 and D is equal to 6. So guys, they want you to create the sequence and they're telling you the first term And they're also giving you the common difference. So they want you to come up with the first 5 terms of that sequence, whose first term is 8 and common difference is 6. So they give you the first term. You must include the first term, guys. So that's the first number in the sequence. Now, to get the next number, you have your common difference, that number, which you have to add over and over again to get to the next one. So you just start adding it. So you add it to 8, and that's going to give you 14. That's the next term. To get the third term, you add 6. That's addition, guys. Add 6 to 14. So that's going to give you 20. To get to the fourth term, you add 6 to 20. That's going to give you 26. And then you add 6 again, and that's going to give you 32. So guys, here's the first 5 terms of the sequence. And just like that, you're good. Now, here's another one. What if they were to ask you to go ahead and find the 80th term if A1 is equal to 106 and D is equal to -12. Now, we have the formula. So we go straight into the formula, guys. Remember the formula is AN is equal to A1 plus N minus 1 times D. So guys, let's identify some things. They gave us the first term. They gave us the D value, which is -12. Did they give us the N value? Yes. This is the N value right there. That's N. So now we go into the formula and just plug in, substitute everything in. So we get A sub 80, or the 80th term. The value of the 80th term will equal to the first term, which is 106 that was given to us, plus the term number 80 minus 1 times D, which is the common difference. So again, guys, grab your calculator, plug this into your calculator to get the answer for the 80th term. And if you plug this into your calculator, the 80th term turns out to be a -842, guys. Try it out on your calculator and see if it works out for you guys. If it's not working out, you should be asking me a question. All right, guys. So that's
Oh, wait,
it.
Miss Althea, how did you get 842?
Okay, so I grab a calculator and I type in 106 plus, in parentheses, 80 minus 1 times the -12. I
Oh, I
close.
thought it was 102. I'm so sorry.
Okay.
My bad.
All righty, guys. So that's the end of the arithmetic sequences, which will be on the test. And once again, guys, I implore you to go ahead and work on the DNC in my math lab in preparation for the test. Okay, guys, so here's the last part of the chapter, and that is the geometric sequences. Now, when we talk about a geometric sequence, we're looking at a set of numbers where each term is found by multiplying. Notice I'm saying multiplication. By the way, I'm going to put division in here too. Remember, multiplication is the inverse of division, vice versa. Okay, where each term is multiplied, found by multiplying the previous term, found by multiplying the previous term by a constant called, this time, the common ratio. And when we talk about the common ratio, guys, obviously we're going to use a different variable for that, the common ratio. We're going to use the variable R for that. to find the next term. So once again, guys, in the geometric sequences, what you are doing is multiplying the previous term by this constant called a common ratio to find the next term in the sequence. And you keep doing it until you're done, guys. Yeah. So for these particular problems, guys, let's say I were to give you this example right here. 3, 12, 48, 192, and so forth and so on. And I were to ask you to find the next 2 terms. So in this particular sequence or pattern here, the first thing you have to do is to figure out, what am I multiplying each term by to get the next one? How do I go from 3 to 12? How do I go from 12 to 48? How do I go from 48 to 192? What am I multiplying each of these numbers by to get to the next one? Okay, so that's the first thing you need to figure out, guys. Now, to go from 3 to 12, you multiply it by 4. To go from 12 to 48, you also multiply it by 4. You've got to multiply by the same number, guys, over and over again to get to the next terms. So, since the problem involves a common ratio of 4, as in you're multiplying every term by 4 to get to the next one. So to calculate the next 2 terms, we take the 192, multiply it by 4. And so this would produce 768. And then to get to the next one, you would take the 768, multiply it by 4, okay? And that would give you 3072. These are the next 2 terms. Once you know the common ratio, guys, yes, it's easy to figure out the next 2 terms. Now, if you cannot figure out the common ratio, all you do, just like with the common difference, pick 2 terms and divide them. Pick 2 terms and divide them. So the ratio would be 48 divided by 12, and 48 divided by 12 is 4. That's how you find the common ratio. So if you have a hard time with finding the common ratio, guys, you could just go ahead and take 2 consecutive terms and divide them. And that will give you your common ratio. All right, so now, just like with the arithmetic sequences, we're going to go ahead and find a specific term. We're going to find the 10th term. Now, this one is a large sequence, guys, so, I mean large numbers, okay? So you're going to end up with a very large number for this one. So remember, the sequence is 3, 12, 48, 192, and they want you to find the 10th term. So here, another formula. So to find the 10th term in a geometric sequence, we use the formula AN is equal to A1 times R to the N minus 1 power. This formula is used to find the nth term, any term in a geometric sequence. So on this one right here, just like with the previous formula, we're going to identify the variables. A1, of course, is the first term. Notice the variables, guys, they are consistent. First term. N is the term number, just like the previous one. AN is the value of the term. And then, of course, the only difference is R, and R represents the common ratio. That's the only difference in the variables, okay? So guys, now that you have your formula, you can go ahead and calculate the 10th term. Now, how do we calculate the 10th term? Well, let's identify what we need for the formula. We have the first term right here, A1. We figured out the common ratio is 4. And we know we're looking for the 10th term. So N is equal to 10. So guys, we're going to the formula and plug it in. So this is what it would look like. A sub 10, or the 10th term, is equal to the first term, which is 3, times the common ratio, which is 4, to the 10 minus 1 power. So now 3 times 4 to the 9th power is how you're going to calculate the value of the 10th term. So you would grab your calculators, guys, and plug this into your calculators. By the way, your power keys on the calculator, you have the delta or the caret, depending on which calculator you have. Most calculators have the delta or the caret. Some of you may have the X to the Y button on your calculator, or Y to the X. Guys, remember to bring your calculator to the test. I will not have calculators. I'm gonna try to remember to bring Scantrons, but I'm not sure if I'm gonna remember. So those of you who will be getting to the bookstore to get Scantrons, can you please make sure you get a pack? The pack costs about $1.50, just in case somebody may need a Scantron. So guys, throw this into your calculator. Don't do 3 times 4. No, 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 no. It's 3 times 4 to the 9th. In other words, you do the exponent first. 4 to the 9th times 3. But let your calculator do it for you. So when you plug it into the calculator, guys, the large number that comes out is going to be, here it is, 786,432. I told you guys it was going to be a large number. Okay, I know you guys are saving all your questions until I'm done with recording. So yes, I'm waiting. All right, guys. So next, find the first 5 terms of a sequence if A1 is equal to 5 and then R is equal to -2. So guys, they want you to find the first 5 terms of the sequence where A1 is equal to 5 and then the common ratio is -2. They're giving you the first term, guys. They're giving you the first term. So
Sorry.
that's okay. Yes, you guys can write on here too. Okay. So they're giving you the first term and they're giving you the common ratio. So here, guys, you must include the first term as part of the sets. They're giving you the first term and they want you to find the first 5, so you must include the first one. Now, all you have to do is find the remaining 4 terms. They give you a common ratio as -2, that number that you keep multiplying each term by to get to the next one. So start multiplying. 5 times -2 gives you -10. Then you take your -10, multiply it by -2. That's going to give you 20. Then you're going to multiply this by -2, and that's going to give you 40, -40. You notice how the signs are alternating, and then multiply -40 by -2, and that's going to give you +80. And just like that, guys, you have the first 5 terms of the sequence. And there you are. Any questions? I don't know. I usually do that. So I'm just asking if you have questions. I automatically do it. But I know you guys are waiting till the end to ask the questions. So guys, let me go ahead and wrap this up with this last problem. And then I will end the recording so you can start asking your questions, okay? So guys, here's the last question. Find A sub 8 as in the 8th term if A1 is equal to 12, R is equal to -2. All right, everybody. So now for this problem, we go into the formula AN equals to A1 times R to the N minus 1 and substitute the values in. So the 8th term will equal to the first term, which is 12, times R, which is -2, raised to the 8 minus 1 power. Now, on your calculators, you would grab your calculators, guys. Be careful with that -2 there, okay? I'm going to ask you to please include the -2 inside a set of parentheses, just in case. In this instance, it's not going to matter, but just in case, guys, plug that -2 inside of parentheses. If you don't plug it inside the parentheses, especially on the test, it's going to make a difference. Because if you want the computer to square or to raise, in this case, -2 to the 7th power, you have to include it inside a set of parentheses and let the calculator do it. So guys, when you do this one, the answer should come out to be a -1536. -1536. All right. So guys, this is where I'm going to go ahead and end the recording because the end of the lesson is official. And so I am going to go ahead and stop the recording